Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll dive into the world of auto-scaling groups, ASGs on AWS, what they are, how they work, and why they're critical for building resilient, scalable, and cost-effective cloud architectures. Let's get started. Imagine having a dynamic team that grows or shrinks based on your workload. Welcome to the AWS Auto Scaling Group, or ASG. At its core, an ASG is a group of EC2 instances working together. But here's the magic. It automatically adjusts the number of instances in response to real-time demand. Predicting exactly how many servers you'll need at all times is tough. Traffic spikes, seasonal trends, or sudden drops can leave you with too much or too little capacity. That's where the cloud shines. Instead of guessing, AWS lets you provision resources just in time. With auto-scaling, you save costs by only using what you need. No overpaying for idle servers, no scrambling when demand surges. And the best part? AWS doesn't charge extra for auto-scaling itself. You only pay for the EC2 instances you use. So what does an auto-scaling group actually do? First, it scales out to handle increased load by adding instances and scales in to reduce capacity when demand drops. You set the rules. Define a minimum and maximum number of instances to keep things within bounds. Plus, it seamlessly updates your load balancer, ensuring traffic routes only to healthy, active instances. AWS Auto Scaling Group keeps your applications responsive, your costs optimized, and your infrastructure agile automatically. Let's take a closer look at how EC2 auto-scaling makes your cloud workloads simpler, smarter, and more efficient, automating operations so your infrastructure can perform at its best. To begin with, load balancing is seamlessly integrated. EC2 auto-scaling works hand in hand with elastic load balancing to spread traffic evenly across healthy instances. When demand rises, new instances are launched and automatically registered with the load balancer. When demand falls, excess instances are retired. No manual intervention needed. Auto-scaling also builds resilience across availability zones. By deploying instances across multiple zones, your application remains available even if an entire data center experiences issues. Think of it as distributed backup power. If one zone goes down, others pick up the slack. Health monitoring is continuous and proactive. Auto-scaling tracks instance health using built-in EC2 checks and replaces any instance that fails. You can go further by adding custom health checks tailored to your application, like monitoring database connections or API latency. When it comes to cost optimization, auto-scaling excels. It lets you combine spot, on-demand, and reserved instances in one group. You can save with spot for flexible workloads, while reserving predictable capacity with reserved instances. Auto-scaling intelligently balances the mix for the best cost-performance ratio. And with spot instances, auto-scaling goes the extra mile. If a spot instance is interrupted, it quickly replaces it, minimizing disruption. Capacity rebalancing even preemptively replaces spot instances at risk of termination, keeping workloads stable and available. For stateful workloads, auto-scaling provides careful handling. Lifecycle allow for clean shutdowns, giving you time to back up state or gracefully terminate. Scale and protection ensures critical instances, like databases or event processors, aren't accidentally removed. Ultimately, EC2 auto-scaling isn't just about scaling up and down. It's about building a resilient, intelligent, and cost-efficient infrastructure that can adapt to change without constant oversight. Let auto-scaling handle the operational complexity while you stay focused on delivering great applications. At its core, an ASG dynamically adjusts the number of EC2 instances to meet demand while maintaining application availability. The minimum capacity in an auto-scaling group is more than just a number. It defines the essential baseline of your infrastructure. Think of it as the safety net for your application's availability. This setting specifies the lowest number of EC2 instances that must always be running, regardless of how low the incoming traffic or demand drops. Even if usage hits rock bottom, or your scaling policies would otherwise reduce the instance count to 0, the ASG will never scale below this minimum. This is especially important for workloads that need to be responsive at all times, such as web apps, APIs, or background services where cold starts would be unacceptable. By configuring a well-thought-out minimum capacity, you're guaranteeing that a critical subset of your application is always up and ready, ensuring reliability, low latency, and a consistent user experience, even during off-peak hours or sudden drops in traffic. The desired capacity in an auto-scaling group represents the sweet spot, the target number of EC2 instances that the ASG continuously aims to maintain. It's essentially the ideal state of your infrastructure at any given moment, carefully balancing the need for performance with the goal of cost efficiency. When autoscaling evaluates metrics like CPU utilization, request count, or custom CloudWatch alarms, it compares them against your policies and adjusts the number of running instances accordingly, scaling up or down until the desired capacity is reached. This number can change dynamically as demand fluctuates, or you can set it manually to reflect your operational goals. In essence, the desired capacity is the heartbeat of the ASG, driving the scaling decisions that keep your workload responsive without over-provisioning. It ensures that you're not under-resourced during peak times and not overpaying during quiet periods. By tuning this value carefully, you give your application the optimal blend of scalability, availability, and cost control. Maximum capacity defines the upper limit on the number of EC2 instances that your auto-scaling group ASG can launch, no matter how much demand increases. Think of it as a safety ceiling, a hard cap that prevents the ASG from scaling out indefinitely and potentially racking up unexpected costs or exhausting service quotas. As the ASG monitors real-time application metrics, like CPU utilization, memory usage, or request throughput, it responds by scaling out, launching new instances to meet demand. But no matter how high that demand climbs, the ASG will never exceed the maximum capacity you've defined. This ensures you maintain control over your infrastructure, resource usage, and budget. Setting an appropriate maximum is essential for both performance and governance. It gives you predictability during traffic spikes and protects you from accidental overscaling, whether due to configuration errors, misfiring alarms, or sudden usage surges. It's your guardrail for scalability, keeping your architecture responsive but always within bounds. The desired capacity serves as the equilibrium point in an auto-scaling group. It's the sweet spot where performance, availability, and cost meet. This number tells the ASG how many instances it should aim to have running under normal conditions. It acts as the target that the scaling policies are constantly trying to maintain, adjusting the group dynamically to match changing workloads. When demand rises above what the current desired capacity can handle, the ASG scales out, adding instances to maintain responsiveness. When demand drops below, it scales in, removing instances to reduce costs. But through it all, the ASG is guided by that desired number, always trying to return to this balanced state. Scaling your AWS auto-scaling group is a lot like setting the perfect thermostat. It's all about finding that balance where performance, cost, and responsiveness align seamlessly. In this section, we'll walk through the core scaling strategies that help your ASG dynamically adjust to changing demand, ensuring your infrastructure stays agile and efficient. Let's start with target tracking scaling. This strategy is like cruise control for your compute resources. You choose a metric, say average CPU utilization, and set a target value. AWS then automatically adjusts the number of instances up or down to maintain that target. It's incredibly hands-off and ideal for steady workloads where a single performance metric can guide capacity. Another option is step scaling, which offers a more granular rule-based approach. Think of it like climbing stairs. You define thresholds and responses, such as if CPU hits 70%, add 2 instances. If it hits 85%, add 4 more. This approach lets you scale proportionally to how far your metrics deviate from the norm, making it great for workloads with well-understood behavior patterns. If you want simplicity, simple scaling might be your go-to. It's a single rule system. For example, add 3 instances if network latency exceeds a threshold. Once triggered, it enforces a cooldown period to prevent excessive scaling actions. Simple scaling works best when you expect occasional, predictable spikes and don't need much complexity. Scheduled scaling is perfect when you already know when traffic will increase, maybe during peak business hours, Friday flash sales, or seasonal events. You predefine scaling actions at specific times, so your application is ready in advance with no surprises. For the most intelligent approach, there's predictive scaling. AWS uses machine learning to analyze historical data and predict future traffic trends, then scales your resources proactively. It's like forecasting traffic before the rush hits, ensuring your application stays ahead without scrambling in real time. And there's more. Lifecycle hooks let you pause scaling actions to run custom logic, like syncing logs or cleaning up sessions before terminating or launching an instance. Meanwhile, health checks ensure only healthy instances serve traffic, so your app maintains reliability without wasting compute. Altogether, these strategies form a powerful toolkit. Whether you need precision, automation, predictability, or intelligence, AWS Autoscaling gives you the flexibility to build a responsive and cost-effective infrastructure. Mix and match based on your workload and let the platform do the heavy lifting, keeping your app running smoothly no matter what comes its way. Imagine your autoscaling group with a secret weapon, AWS Warm Pools. These are pre-initialized EC2 instances that wait on standby, ready to spring into action the moment traffic surges. Instead of launching new instances from scratch, which can take time, your ASG can tap into this reserve pool of already configured instances and scale out much faster. By default, the size of a warm pool is calculated as the gap between your auto-scaling group's maximum capacity and its current desired capacity. But AWS gives you full control. You can customize the size of this pool based on how quickly you want to respond to demand. Warm pool instances can live in one of three states, each with its own cost profile. The most cost-effective is the stopped state. Here, the instance isn't running, so you're only charged for attached EBS volumes. Ideal if you're preparing for occasional bursts of traffic. The hibernated state goes a step further. The instance shuts down, but retains its memory contents on EBS, allowing it to pick up right where it left off. This gives you faster recovery with a small storage cost overhead. Lastly, there's the running state, but that's generally not recommended, since you're paying for full compute resources, even if the instance isn't actively serving traffic. The true value of warm pools is in how they balance speed and cost. They let you scale quickly, essential for workloads that experience unpredictable spikes, like sudden traffic surges or time-sensitive batch jobs, without the ongoing cost of keeping extra instances live all the time. It's a smart, efficient way to ensure your application is always ready to respond without overpaying when things are quiet. Auto-scaling groups, ASGs, and Amazon Machine Images, AMIs, work hand in hand to ensure your infrastructure scales efficiently, consistently, and securely. At the heart of every ASG is a launch template or launch configuration, which includes a reference to an AMI, essentially the blueprint used to create new EC2 instances. This tight coupling ensures that every new instance spun up by the ASG is identical in configuration, software stack, and operating system, creating a reliable and predictable environment. By using custom AMIs, teams can pre-package their applications, dependencies, and configurations, dramatically reducing instance boot time and making new instances production-ready the moment they launch. This not only improves performance during scaling events, but also reinforces security and compliance by using vetted, hardened images. AMIs also support an immutable infrastructure model, where updates are rolled out by creating new versions of the AMI and updating the ASG's launch template. This allows you to perform controlled rollouts through instance refreshes, ensuring minimal disruption and maximum confidence in deployments. Since AMIs are region-specific, organizations operating across multiple AWS regions must ensure that AMIs are copied and referenced appropriately in each regional ASG. This maintains consistency in deployments, regardless of geography. Finally, AMIs play a critical role in cost and performance optimization. Using lightweight or purpose-built AMIs can help reduce EBS storage costs and instance startup times. Overall, the connection between ASGs and AMIs forms the backbone of scalable, efficient, and reliable cloud operations. Monitoring your auto-scaling group, ASG, is critical to ensuring your applications remain resilient, cost-efficient, and high-performing. AWS provides a robust suite of tools to give you full visibility into your ASG's behavior and health. At the core of ASG monitoring is Amazon CloudWatch, which automatically collects and publishes key metrics such as the desired, in-service, pending, and terminating instance counts. These metrics give you a real-time pulse on how your ASG is performing and how it's adapting to changing workloads. To stay ahead of issues, you can set up CloudWatch alarms based on thresholds, like CPU utilization or the number of healthy instances. When these alarms are triggered, they can notify your team or even invoke automated recovery actions, helping to prevent outages or performance dips. ASG health checks go beyond just system-level metrics. By default, they rely on EC2 instance status checks, but you can also configure them to work with Elastic Load Balancer, ELB health checks, or define custom health checks to monitor application-specific signals. If an instance fails, the ASG takes swift action to terminate and replace it, ensuring continuity. When you use lifecycle hooks, monitoring becomes even more critical. These hooks allow you to pause scaling actions so you can perform tasks like warming up an app or backing up data. Using CloudWatch events, now Amazon Event Bridge, you can track these hook states and integrate them with automated workflows. To get even deeper insights, services like AWS CloudTrail, AWS Systems Manager, and AWS X-Ray can be integrated. These tools help you log infrastructure changes, run diagnostics, and trace request-level performance, all within the context of dynamic scaling. Together, these monitoring capabilities make auto-scaling not just reactive, but proactive, equipping your team with the tools to maintain stability, optimize costs, and deliver reliable user experiences at scale. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.